So Santa is saying that she was going through the installation guide. Has everyone installed, or will you walk us through it today? Okay. So okay, I'll walk you through the guide once, and I think what I have understood is using a central server like this one, the one we are using right now, the cloud one which I have provided in the manual is a better option. And so as of today, uh, the best option to me uh, uh, seems to be the putty one, because try.mongodb.org is actually very limited and does not give you the full functionality. So using putty and then connecting to the server with the login password is one of the good options. But uh, okay, so let me check. So in the installation guide, in the top itself, you will you will see that so there is the second point in from the top, just at the top of this instructions, it says that protocol is SSH, server is one number, and then login is student, and there is a password. Shreya has not logged in yet, and Bhagwat is also not logged in yet. So I'm actually trying to little bit delay. Never mind. Okay. Hi Umang. Hi Umang. Good morning. So we were talking about installation instructions today. Basically, you need to install MongoDB one way or the another to try out and having the hands-on. So first one was to I'll just go through the installation instructions once to give a big clarity on what we are trying to achieve. First one is the quickest one, and the quickest one is to use try.mongodb.org. Is the easiest way to try out MongoDB console if you are just uh, if you are just trying to test whether your JSON is valid or not, and whether your command is right or not wrong. So this is a quickest but a very limited one. For example, you can't create multiple databases and other parts. So this is just very rudimentary. The second one is the servers we have bought. One of the servers I am giving it here. So the server IP address I have given, and login and password, and you have to connect it via SSH. You have to connect it via SSH. And on Windows, since SSH command is not installed by default, what you need to do is you need a putty client. So you'll have to download putty and then install it. And the other way is to use a browser-based system as mentioned in the link. But that's not a great idea. And installing putty is not very difficult. Okay, so the putty binary is a little confusing. So I suggest that you use a putty installer. There is a putty installer.exe which has everything. Okay, and that should do just fine. I think I have given a direct link to the downloader, and it gives a putty installer. Yeah, so the direct link will do good. You don't have to do anything. And on Linux and Mac, you have to give a command like ssh student @IP, and that should do good. Oh, okay. So, okay. So, Umang, are you able to see the installation guide? And sometimes the first one is 0 and second one is O. And I think you should better copy paste because all these passwords are randomly generated. Umang, the installation guide is in the first session itself. Shreya is saying that she could not download the zip file. Okay, she could not install, so she downloaded a zip file. So Shreya, just give me after this session, give me a in the Hangout itself. You can give me a remote control of a machine. I can have a look at it, and then we'll see what's the problem. Probably Putty should not be difficult to install because the installer is good enough, but I don't know how it behaves on 32-bit. I don't have a 32-bit Windows right now to test it out. Okay. So, Umang, were you able to find the IP address and the installation instruction? Yeah, at the bottom of the first instruction course page. So just below the recorded session, there is a link for installation instruction in the section 1. In the session 1, below the video, it says installation instruction. Click here. Okay, Umang? Sakti, I will be discussing more commands today for practicing MongoDB, and so you don't have to worry right now. Okay, so installation instruction, I am anyway copy pasting the link here also, and yeah, good, good. So Gaurav, were you able to log into the SSH server? Sakti? Okay, okay. Great, great. So I think everybody should be able to do it. Okay. And just after this session, you try it within like half an hour and give me a call immediately so that we fix this problem before you go to some other work. So that over the week you will be free and you'll have no, mental blocks to try out MongoDB. And just after this meeting, just take 15-20 minutes and get your MongoDB in line. Okay. So that on weekdays when you're busy, even if you have 2 hours available to you or 1 hour available to you, you can give a shot to all the assignments and give a try it out by yourself, or you can try everything which we are going to discuss in this section today. Okay. Great, great. Okay, so now I'm starting the usual presentation, and cool. So the title today, the topic of the discussion today is the CRUD operations. This is very important session, and we should be, and it is going to be little heavy today. It is going to be little heavy, and because it covers a lot of aspects, and there might be some topics which are not very clear right away. So do not panic and keep asking questions. There are some topics which I'm going to deep dive, and some topics I'm going to little go over the surface and move forward, because those topics are going to come again when I discuss architectural details. So today we are going to discuss how to read and write to MongoDB. How does the MongoDB internal function? Okay, great. So now let's move to the next slide. So these are the normal things which we follow at nobigdata.com, and this is nothing new. About me also nothing changed since yesterday, and this is the course content. So we are going to talk about installation guide, getting started, CRUD operations. Okay, but the main concern today is the CRUD operations. Installation guide, installation and getting started should not be an issue now. What are the operating systems you guys are using? Can you just quickly write in the chat window so that I can plan my stuff accordingly? Okay, so Sakti is using Windows 7, Umang is on Mac, and Windows 8 and Windows Vista. So except for Umang, everybody is on the Windows, and for everybody the putty should be fine. And Umang, for you the easiest part, it may not be easy. I'll just send you separate instructions for macOS, because when you install using a default commands, it gives you an older version on Mac. Okay, but for time being, this server is good. Server is good for you. Okay, well, SSH is fine. Yeah. Okay. So in today's class, we are going to first go through the quiz, and did you guys have problem in going through the quiz? Was any question ambiguous, or do you need more clarity on something with respect to the quiz? Some of us have been able to complete the quiz. Right, right, right. Okay, okay, okay. So, welcome Bhagwat has also joined, so the whole class is here. And so, Bhagwat, were you able to go through the quiz? Okay, okay. I just, uh, I'll have to mute you. So, basically, we use the chat for answering the question and asking. Otherwise, it'd be too much of noise. So, the question is that, were you able to go through the quiz? Were you able to take the quiz? Oh, oh, you did not log into the course page? Okay, okay. So you can take the quiz after this. There will be two quiz now, session 1 and session 2, and they'll be available on your course page. When you log in, you see the My Course tab at the top right, and when you go into that, select the first tab, session 1, and then session 2. Go through both the quizzes, and there'll be an assignment today after this class other than the quiz. Okay, so I mean, there was only minor confusions with respect to the quiz, I suppose. And right, right, right. Great. So I'm seeing the results of people in the quiz section. People have done really good in the quiz, and I mean it's better than my expectation. Okay. So okay. The next topic which we are going to discuss is the recap about an analogy to RDBMS, and then various details about various topics, such as how does I'm going to start with the tough topic, which might sound a little boring in the beginning, but this is the basis on which the whole MongoDB stands, and that's why I've moved it to the front rather than back, which is storage system, and it is actually required to know all of these. Okay. 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 Great. Yeah. So first of all, let's get back to the analogies to RDBMS. So you have, these are recap basically. You have something called a database, then you have collections, then you have documents, and then you have keys and values. Okay. Database is similar to your RDBMS database, and a database is nothing but a collection of collections, a group of collections which belong together. Okay. And a collection is a group of documents or group of objects that are of the same family, and they belong together. The almost all of the collections generally have same set of attributes. Sorry, all of the documents in a collection are have same set of attributes, almost not identical. So one document can have different attributes than the other one in the same collection, but as a matter of practice we try to keep only the documents of a kind in the same collection. Although we can add every document into the same collection, but we don't do it because when we are doing an operation on collection, so collection is equivalent of a table, and collection is an equivalent of a table which contains multiple rows, and a row is an equivalent of a document, and key value is equivalent to column and its value. Okay. Here it is going to be key field and value or key and value. Okay. And uh, MongoDB also has a concept of indexes, same as your traditional database. And then instead of a join, the way we have a record spread over multiple tables in RDBMS, we don't do that in MongoDB. We try that we don't have to join two collections together like we do in RDBMS. Okay. So to avoid that, what we do is the things which are one-to-one relation or multiple relations, we try to embed them together. And that's this section which we are going to deal with in data modeling in chapter number 3, session number 3, which is on next Saturday, coming Saturday. And in RDBMS, there is a primary key. In MongoDB, it's underscore ID. And underscore ID is the common attribute. I mean, it's not optional. The ID is not optional in case of MongoDB, while in RDBMS it used to be optional. Every collection or every table is supposed to have an ID, and that's a primary attribute of every NoSQL, because that's the basis on which the data is selected for the storage, that this key is going to go on to this server and that key is going to be on another server. So the common attribute across all the databases, all the NoSQL databases, every NoSQL database has a ID or a key. Okay, so there is no NoSQL database which does not have an ID. Okay, whether it's column wide or document oriented, key value pairs, or a graph based. Everybody has a key for the record. Okay. unlike your traditional database, which may or may not have a primary key. Now, how many IDs can be created for a collection? How many IDs can be? That's Sakti's question. He's asking how many IDs can be created for a collection. So it's not, ID is not per collection, ID is per document. Meaning every row of the table is supposed to have an ID, or in the vocabulary of MongoDB, it's called every document is supposed to have an identifier in the collection. Okay, so as many as documents are there, that many IDs would be there. And if you, I'll come back to in detail. This will go in detail again and again. So let's talk about storage. How does, since now we are vaguely familiar with what is MongoDB, and we are vaguely familiar with, there is something called a database, there is something called a document, and there is something called a collection, and there is something called field values. Okay, so the data model which MongoDB follows is that whenever you are trying to store any JSON, underlying is a BSON document. Okay, because MongoDB is supposed to store every kind of data, not only plain text. And for that, BSON, which is a similar format as JSON, you can just for time being think that it's a similar to JSON format, which can support all sorts of non-printable characters also. Okay, and I mean it's just basically similar to JSON with a which can store non-printable characters also. In terms of, it will be keeping everything things in terms of low level bits, and not in terms of numbers and strings right away. Okay, and so we under the hood, MongoDB is storing everything in BSON document, and each BSON document is stored in something called a record. Okay, and there is a space left in the record, so that when we are making a change in the document, it fills that space. Okay, so the record is nothing but a document and then a space, an empty space. This empty space is called padding, and then after this will come the another record, and after that will come another record. Okay, so when you have like say 10 documents you are adding into a collection, so each document will be stored in BSON format, and after this there will be space left as a strategy, so that when we are doing an update or we are trying to make changes into the document, there is always a space, and it expands there, rather than we try to disturb everybody else after this, or we try to take this document from this location and put it elsewhere. Okay, it's like having a box to put your stuff and leaving a little bit more space so that you can put more of your stuff in that box without having to realign everything. Okay, so that's a record. Record is like a box inside in which you put your document. You don't have to worry about this. These are internals to MongoDB, but you need to know, because when you are using MongoDB, based on how you are trying to use it, this space is generally double than what your document size is. sorry, equal to your document size based on the strategy. There are two basic strategies I will explain just now. And then, so when you stored say 10 MB of data, chances are that MongoDB will consume 20 MB of data, uh, 20 MB of disk space, because it has left that space for the time when you are trying to update the records. Okay. Okay. So yeah, yes, Gaurav, I just saw your answer. Yes, it can be complex. It can be complex. Yes, you are right. You can when you are defining your ID, right? You can say ID colon and then angle brackets and then the curly brackets and then put your set of keys. I'll describe that later. Okay. And so this extra space we call it padding, and this is just to keep in mind how it is going to store it. All these records or all these records which contain your document are stored contiguously in the on the disk. Okay. It's not like there is a space between the records. They are continuous on the disk. And MongoDB keeps a track of basically when you are trying to move where is the record line. Okay. And database constructs. Okay. As I just described, the database contains multiple collections, and we always keep multiple collections which belong to the same application or same are similar in behavior or related in nature. They are kept in the same database. And so when you are writing to a database, MongoDB internally provides a lock on the database so that if there are two people writing to the same database, they do not corrupt the data. And this is only valid for a single instance of database. It's not that we cannot lock two two databases on the same machine or other machines. So if there is a database, if you have multiple servers having the same database, and so you cannot lock both of them together. I'll describe it when I'm discussing the architecture further. Right now, just understand that each database is having a distinct lock. When a person is trying to write to a database, it might mention that I want to lock this particular document in this database. Okay. So this is the basic structure of how the data model vaguely is. How do we get post to the database simultaneously? Bhagwat, I did not get your question. How do we get post to the database simultaneously? During update for a document, if the document is running out of space, how do we resolve it? That's a good question, and next screen will answer it, Sakti. Is there any size limit for the document? That also is coming up. In RDBMS we have row size. Okay. Okay. DB is made up of collections. Yes, that's right. Each DB is a collection of collections. So Bhagwat, you can actually go to create multiple shells and try to uh, create or I mean insert or update a database simultaneously from the shell. Sometimes I think so. One distinct lock means we can only write to one record in one collection only. Yes, yes. So there is basically a write lock which avoids corruption of the data when two clients are trying to write to a database simultaneously. Gaurav's question is write lock on DB or collection level, as I think collections are mutually exclusive. So DB level, it's very generic one, because when you are inserting or updating data, it will have to update indexes and other parts, and that is why it is called that. It's not on DB level. It's just that each DB has a separate log than the other one. Okay. We will discuss the locking again later. This is just a surface of what it is. Okay. Bhagwat's question is, how can we post from a web page to the database simultaneously? Right. So what you could do is, in your code, when you're connecting, when you're creating connections to the database, you can have multiple threads. In case of a web page, you may not have multiple threads, but you can, spawn a background processes who are connecting to the database parallelly. And even in the web page, you can actually create multiple threads and then send it to the database. And once they all finish, you wait for some time and then return. So that way you can post to the database concurrently. Okay. Okay. So I think time is to move on, because lots of questions will be answered in the next screen. And when we are talking about storage, there is a concept of a journal. We can enable a journal on MongoDB. Okay. And this journal helps us in a lot of ways. What does a journal do? Whenever there is a write operation coming from a user, it is quickly written to journal, so that, and then it is passed, understood, and propagated to various machines. But the way an accountant does a job, right? So when an accountant uh, m- uh, gets a new transaction, instead of making a double entry, making sure that it belongs to this person, that person, and all that sort of background job, which does not need to be done right away, it takes the input from the user. The accountant takes the input from the user and make a journal. It's called journal entry. And then after journal entry is done, in it makes entries at various places and finishes the job. Okay. So journal entry is a interesting concept to avoid the loss of data. Say for example, when we are quickly trying to write, and database is not yet able to finish distribution across the system, and is not able to update the indexes right away, and the power goes off. So half of the indexes are written, half of the indexes are not written, and there is all sorts of problems might occur, and you might lose your input, whatever data input you have given, since it has not updated things properly. Although the consistency it might maintain using an internal logic, but it might not be able to maintain the it might lose your data. That is why what it does is, it takes your input, quickly saves it in journal, and then gives you a feedback that I have written it to journal, and once I am done, then it will be updated at various places. Unless you are specifically asking the database, okay, give me a confirmation right away that you have updated till the secondary level, till all the servers are updated. In that case, MongoDB will give you a response of finish only if it's written to everywhere. And that's what we call a journal. So journal just takes your entry, keeps in the memory, so keeps in the disk immediately, and it starts processing the other journal entries before you have been any way be processed. Okay, so this is how, this is a very big use case of journal when there is a failure of network, failure of power, failure of all sorts of unpredictabilities there. And when we are dealing with lots of records, billions of records, there are, the failure is a part of the process. It's not an exception. And that is why they have come up with an idea of a journal. Okay? And it gives a guarantee that your data has been written. It provides a crash resilience. Although when you use a journal, it hits a performance a bit because it's the same disk on which a document, when the final everything has been finished, all indexes, everything are going to be written into the disk, and journal is also going to be written into the disk. So the disk becomes a bottleneck. Okay, so this hits the performance. So a journal, the style which people use is that keep the journal in a separate disk, so that while writing to journal, you are not disturbing the disk in which the writing process of actual document is going on. Okay, so this is what is called a journal. Before, so MongoDB will take your data, whatever it is, put it in journal, and then when it's time, when it has finished processing the entries before your entry in the journal, it will process your entry, and then it will form the record. It will form the document. BSEN document anyway it has formed already. It will take it up, create a record, as I told you in the previous screen, and store it on the disk wherever the space is available. Okay, moving on. Now storage. The record allocation strategies, as we discussed, as you can see in the screen, there are these contiguous blocks of records. You can see different color means different records. Okay, in each of the record there would be some space left. Okay, and how should this space be left? I mean the padding part, how much should we leave it when we are when a MongoDB is storing a record? How much space should be there for padding? Okay, how much extra space should be allocated for each document? Okay, how much? So there are two strategies which MongoDB follows. One is a power of two-sized allocation. Okay. Okay. And in which each record size is a power of 2. So for the first time the record size will be 32 bytes, and the moment you make another update it will become 64 bytes, and so on. Okay, and so on, it will keep on growing that way. And the other strategy for the record allocation is exact fit. These are good only if you are exact fit. I mean the padding is not 0, but it's a very small size padding. Okay, very small size. Initially padding is the when you are writing the document for the first time, the padding is almost 0, and when you are writing for the second time, it's equal to the actual document, and for the third time the padding will become twice the size of the I mean the whole record size will become twice the size of your document, and that's it. It doesn't grow beyond twice the size. Okay. So padding factor, which basically record size is equivalent to padding factor multiplied by your document size, and the padding factor grows from 0 to 2 on each update. So for the first time when there is a no data at all, there is a 0 record, and then when you are making the first insert it becomes 1, and then it becomes 2 in the second update. And this is one strategy for record allocation followed in case of a MongoDB. Okay. So these are record allocation strategies followed by MongoDB. Okay. And now let's start with the basic commands. So Mongo is the client used by basically from where you connect to the database. You go to the command prompt, type Mongo. If you have installed MongoDB on your server, and then it should connect to the server. Right, if you don't specify any of the options on the command line, it will connect to the local machine itself. If you want to connect to a remote server using Mongo client, you can do Mongo space port, and then you can also specify uh, Mongo space IP address colon port slash database name. So it will directly connect to that particular server with the port, and uh, and then it will change the database to something else. Okay. And DB, when you set DB on the command prompt, Mongo gives you a console whereby you type all the commands, and on after you get the console, uh, you will type DB to get all the list of see the current database, and then say show DBs. It will show you all the databases in this machine, and then say use DB. This is use DB. Okay, not use DBs, use DB. It will switch to the particular database, and then show collections. It will show you the list of collections in this database, and there is a nice help command. So help without brackets is a command which gives you a list of all the commands in the system. And if you say db.help with the brackets, it's a function on DB. It's a JavaScript function on DB. It will give you a list of commands supported by DB. Okay. And if you say if you want to know what are the all operations you can do on a database, you on DB level, what you do is db.help, and then if you want to know what are the operations you can do on a collection, type db.x. X can be anything. Okay, db dot whatever you want to say, db.mycollection.help. It is equivalent to db.x.help, and it will give you a list of all the commands which you can do at a level of collection level, at the collection level. And then further, if you say db.mycollection.find and then .help, it shows you what are the operations you can do on the top of find function. And that's a strategy followed at the help level. We keep MongoDB keeps on giving you help at every level. Okay. 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 That's a very valid question, and thank you, Gaurav, for reminding me this. Okay. So basically, when I talked about storage, I talked about record sizes, right? And so what happens, say you added a record, added a document which added a record plus containing some of the paddings, but when you are making an update, you made an update, and now the new update wants the, I mean, is not fitting in this size, the padding size. Okay. When you are trying to update a document, it is not fitting into this space. So what you do? You so MongoDB takes up this document from this location and puts it somewhere else. Okay, and that somewhere else is maybe at the end of the whole records, all the records, or it may be at the it may be at the some other location. Because the moment you are taking a record out of a place, it leaves a space, and that is what called fragmentation. So this is a hole which is left when you are taking out a record from a place, because a document could not fit into this record because there was not enough padding available, and so you take out this record and put it somewhere else wherever the space is available, and leaving here a hole, and such hole lead to a lot of fragmentation. Okay, so in case of exact fit location, exact fit strategy, the such movements are going to be more and fragmentation is going to be more, while space utilization will be very efficient in case of exact fit. But in case of power of two sized allocation, where every time we store the data in terms in the powers of 2, which means as the data keeps on growing, the padding also keeps on growing pretty fast. Okay, so imagine that you are having a space of uh, say 32 MB available for you. Now you want to store 33 MB. So what MongoDB will do in this strategy of power of 2, it will make a space for 64 MB for you. Okay, so there will be a lot of wastage of space in the power of 2 sized allocation strategy, but there will be less of movement. Now since we have created a 64 MB size of allocation for 33 MB data document, what it will do is it will give you a lot of chance to update this document further before the movement happens. So there will be a less of a movement and less of a fragmentation, but waste of space in case of power of 2 sized allocation. In case of exact fit allocation, there will be a lot of movement if there is updates of database, and there will be a lot of fragmentation because the if the data updates frequently. So exact fit allocation is good for the cases where you don't intend to update a database. I'll come to this point later. Why do you need it? Okay, in what cases do you need it? There is something called capped collection. In those cases, this is exact fit strategy is better. Since it stores in contiguous history, so if record grows 3 to 4 size or maybe or more, will it replace that particular record? So I think I've answered your question, Gaurav. It will move it to, just confirm me if you have, I've got the answer. Otherwise, I'll explain it to you later again, because this is a very crucial point. Okay. So the moment you hit you are trying to store more data, more bigger document into a record size where padding is not sufficing your need, you move it to another location, maybe at the end or into another fragment available, and that is how MongoDB does. So MongoDB has to keep track of all the fragmentation available on the disk. Okay, so that when there is a movement required, it will move the document there. But okay, so Bhagwat's question is, in the exact fit, will it? Yes, it will still move in the exact fit also. So Sakti, Umang, Shreya, should I move on or explain further? So the size of the document is going to grow. Okay, Bhagwat, I'm trying to answer your question. So MongoDB will not force you not to change the document. Okay, all it will do is, since the strategy is saying that we can only allocate this much of space, this much of padding more for you, it will keep on moving the data, moving your document in the disk to fit your need. Okay, it will move to the fragment or at the end of your at the end of the storage to meet your needs. Okay, and that's why there will be a too much of movements if there is an updates in case of exact fit strategy. No, Sakti, it does not split the document. Okay, it does split the document. There is a command called MongoFS, which is a client and which does a favor for you when you are trying to store a big document onto a cluster. So MongoFS splits a large file and makes small pieces in a form of collection or a BSON documents and asks the MongoDB to store those documents. Okay, so uh, in case of large document, you will have to build a client which does the splitting for you. MongoDB does not do the splitting inherently, but MongoDB has provided you a couple of client-side libraries, or you can say a kind of utility package which helps you splitting very large collections. Okay. Yeah, Bhagwat's question is, yeah. So, is there a concept of defragmentation in MongoDB? I think there is a command, but I'll have to revive because I haven't used it. Though I have read it, that there is a command which helps you shrink the data, but move the data such that there is no fragmentation. But I haven't used it ever because disk is cheap. Disk is cheap for you, though unreliable, but cheap. And so people don't really care about so much about saving the space when it comes to when we can add more and more of our cheaply available disks in the house around. In an organization there are always so many hard disks available, you keep on adding here and there and let MongoDB does the job. So I haven't used defragmentation per se, but as an admin people would like to know. Okay, so I'll have to go through it once and then see. Okay, okay, that's a good question. So sometimes asking after the storage, large document will become contiguous again. The large document which is split by the client. So let me explain to you that there is this client called MongoFS. What it does is it creates, first it creates a document which, first, say you are trying to store a video of 70 GB. Okay, say you have a Blu-ray, nice Blu-ray, and you want to store it on the MongoDB database. So you asked MongoFS ki store this file onto the network, and it takes this file and splits it into smaller sizes and stores it on the MongoDB various servers of MongoDB in a small size documents. So first it will split it into small files, give it to MongoDB, and note down each document ID returned by the MongoDB. Now based on this, it will make a separate document containing all these pieces, ID of these pieces, and make a separate document and store it in MongoDB. Okay. And this is how, so internally MongoDB will consider each piece as a separate document, and MongoDB has no knowledge internally about each piece, but MongoFS, who created these splits, would know everything. So when you ask MongoFS, hey, give me this particular video which I gave you from this location onwards, so it will give you that file from that location onwards, and it will become a contiguous again. Okay, so I hope I answered your question. Yes, Bhagwat, you are right. Okay. So this is the basic help command, and use these commands whenever you get stuck, and feel like an explorer. Go through more of this. It'll be nice. And mongodb.org will also help you when you get stuck. I mean, you just go to Google and search, and Google will give you the best answer. Or you just let me also know that when you're stuck, I can also help. So it doesn't understand any formats. Bhagwat, I'm trying to answer your question. How does it understand the formats? It doesn't understand. It just considers it a binary, and it goes byte by byte, it splits it and saves it. And when we say give me from this location onwards, we don't say give me the 5 minute onwards video. We say that give me this byte onwards. Okay. So at application level, you will have to form a correlation between bytes and the timelines. If you are trying to build an application which jumps to various locations in the player, and then you get the data and play. Like a video, how does it understand formats? The client makes sense. Right. You're right, Bhagwat. That's what I'm saying. So, so the data format, as I have already described, there is a JSON and there is a BSON. BSON is for storing binary data, as in case of I just explained that when MongoFS is trying to store a binary file, it will form BSON and give it to MongoDB through the API. And when we are interacting, we are talking in terms of JSON. All the commands, everything, we will be providing in terms of JSON. Okay. So although BSON we need to know what it is, but we'll be working in terms of JSON always here in during this discussion. Okay. So JSON is nothing but a JavaScript object notation. It's very widely used. It is not limited or property of MongoDB or now browser. JavaScript is widely used across all the APIs, and JSON is widely used all across APIs. At most of the places, JSON has replaced XML completely. Okay, except for markup languages where XML is still widely used. JSON has taken a priority because it is a compact format, because it doesn't have that end of line, and parsing a JSON is a easier game than XML, and it's less confusing because there is no concept of attributes and values, because there is always a confusion, should I create a child node in XML or create a attribute. Okay, so from that perspective JSON is quite simple and compact as compared to XML and has taken a priority, and it's a very general open and widely used. At Amazon also we have moved our APIs to talk in terms of JSON and respond in terms of JSON. So while talking, instead of you talk comma separated key values and then the server replies you comma separated key values, you talk in terms of a well defined format. Because say you are saying give me the data about A comma B comma C. Now what if A as an string also contains a comma? Say you are trying to send the names of people. So these sort of confusions, to avoid these sort of confusions, people zeroed down on a format, and that format interestingly came from JavaScript. Okay, and it's very simple. On anybody who has been has seen Java or C or C++ syntax should be able to quickly correlate what it looks like. Okay, and moreover it is also analogous to what we have learnt in our basic education, where square brackets, curly braces, and uh, brackets are used to signify various kind of things. So and let's just see how does a JSON looks like. So l- so the basic part of the JSON is an object. Object is nothing but these diagrams. Don't get intimidated by diagrams, I'll explain. So this is how a JSON looks like. On the left hand side is the, we call it sort of a grammar, or a diagram which represents grammar. It says that the object is things surrounded with curly braces. And what is things? Things are string colon value, then comma, then string colon value, then comma. It goes like this. So if you are traveling, if you travel through any line, it will form an object. So say if you go from the above line, this one, so it becomes a curly braces, empty curly braces, which means this is an empty object. Which if you go through the middle line, you encounter string rectangle first, then colon, then value rectangle first, and then curly brace. Which means that object is a string colon value, and then curly brace is ended. But if you just go into the loop again and put a comma, then it will be like curly braces, a string colon value, comma, string colon value. So as you traverse across this, you will be forming new forms of object, and that's how it is described. So object is nothing but things are in the curly braces, which things are comma separated, and each thing is string colon value. It's as simple as that. And in the right hand side you can see name colon Sandeep, marks colon 50. Okay. This is one object containing two things. First thing has to key as name and value as Sandeep, and that. Now array is comma separated value of comma separated values. Okay, and a value is what? A value can be a string, can be a number. There is no concept of int and double here. Everything is a number, whether it's int or float, or a decimal number, or integer or decimal number, or long, or all those sort of format. Instead of that, it keeps it simple, saying everything is a number. Okay, and then we have value. Interestingly, can be another object. Okay, another object as we described in the above. So and it is so this format is called recursive. So value here can be further any other object, and that's when we reach to this level where we have documents inside documents. Okay, So an object is a key value comma separated key values, colon separated key value, and which are comma separated from each other, and then array of values. Array is a comma separated values, and a value further can be an array. Okay, it can be a number or a string, it can be further an object, it can be boolean true false, and it can be also null. So that is what a JSON is. I Did I confuse you guys? Okay. Okay, Sakti has got a good question. Yes. So in case of MongoDB, you can put a double quote around the key, as well as you can skip it. So by default, key is only a string in case of general JSON, while MongoDB also accepts integer as the key. Okay. So this is how a JSON looks like. So MongoDB does behave a bit differently from standard JSON. For example, MongoDB accepts single quotes also, as opposed to the double quotes. Okay. And when you have to put a double quote inside a string, you put a slash and then double quote. If you want to put a slash in the string, you put double slash, and so on. It's similar to what we have read in case of JavaScript or C. Okay. So I hope I did not confuse you guys. Yeah. Okay. So I'll just go through JSON exercise. This will help you a lot. So tell me which are valid JSON? A, B, or C, or D? Quick. So can you see it clearly? Bhagavad is saying B and D are the valid JSON. Okay. Okay. So Shreya, right? You're right. So C is not a valid JSON. Okay. A is not, because those comma separated things need to be in the square brackets. Okay. B. So A is not a valid JSON because it doesn't have square brackets. Sandeep comma Giri need to be in the square brackets. And then B is valid because it's in the square brackets. It has fixed the problem of the A. And then you have C. C says name colon Sandeep. Ideally a string need to be in the double quotes. Okay. So C is not correct and D is correct. Okay. D says 12.23. Although 12.23 looks like a number, but for JSON it's a string because you have put it in the double quotes. Okay. Great. So let me check who. B and D, yes, Bhagwat was right. Gaurav, yeah. So you got the answer. Okay, great. So let me. That's a very nice way of doing it. Samta is saying, can you correlate B and the grammar? So if you see, this is an array, right? Array. Uh, where is my next one? Okay, here you go. So there is. So this is an array. Okay, and value can be an array. This Sandeep comma Giri is an array in the square brackets, and value can be an array. So array is how it looks like, and then value can be an array, and object is string colon value. So first, let me just take it here. I'll be better to explain. So you have this in place. So first of all, this name is equivalent to the first, in the first screen, name is equivalent to the string, and the value is equivalent to the things in the square bracket here. This is value. And then further, when it comes to array, square bracket is hit here, and then this is one value, comma another value. Okay. So it's a composition of all these three rules. First rule says an object is a comma separated list of string colon values. Okay. And array is a list of array is a something enclosed in square brackets which are comma separated values, and values can further be uh, values can either be primitive types, which is string and number and true, false and null, or it goes back to array or object. So it keeps on, recursively going back and forth. In very plain language, it's simple, but if you try to do it through mathematical diagrams, it becomes little difficult to express. Okay. So hope I explained? No. Good, good. Sorry, I showed you the answers. Okay. In the next exercise, again the same exercise, which are valid JSON? You have A, which are the valid JSONs out of this list? Because JSON, learning JSON is important in today's world. almost every software talks in terms of JSON these days. Shakti says that A is valid. I doubt so. Gaurav is saying B is valid and E is valid. And Gaurav, why not C? C? Is C not valid? In the E, you can see there is a comma at the end of the after Sandeep. And Shakti, if you see D, so okay, let me tell you which are. I'll just change question to suit myself. Which are valid JSON objects? Okay, so Shakti, just to make it correct, which are question is which are valid JSON object? Although D is a valid JSON, but D is not a valid object. Exactly, Bhagwat. Okay, okay. So, Bhagwat, are you changing your answer? Perfect. So A, why A? Why A? Do you see anything wrong in A? Think about it again. Exactly. Exactly. Okay. So who was correct? Samta was correct. And okay. Okay. Oh, great. So, yeah, and the in case of C, right, it's basically a string colon value, and uh, it, the value can be either in a double quote or can be without double quote. So it's okay because if you see in the diagram, if see in the diagram, ideally the key need to be in the double quote, right? It says object is string colon value and string is always in the double quote. But in case of MongoDB accepts without the double quote in the key. Okay, so it is okay to have no quotes or with quotes in key. Okay, moving on. Because this exercise I have kept because when you are doing various operations in case of MongoDB, you will think that MongoDB is misbehaving while your JSON will be invalid. You will miss out one thing or the another. Okay. So in E, I use double quotes. It becomes valid. In E. Right, right. You are right, Sakti. If you use double quote in E, it becomes valid. Though it is accepted by MongoDB. This is particular thing I figured out while making this quiz, that this is actually this particular portion I have written there accepted by MongoDB. E is a special case. It automatically converts 12 into a string. MongoDB automatically converts 12 into a string and stores it. Okay. Although from the standpoint of JSON, it's an invalid one. So you can say that it's a little bit of teaser. Okay, now let's talk about collection. A collection is a collection of documents. It's equivalent to a database table. A collection is a collection of document and it is equivalent to the database table. There is no schema restrictions unlike tables. In database tables, you always define, while creating tables, you say create table with this column with this data type and this much of size, and those kind of restrictions you define upfront while creating a table. In case of collections, you don't have to define a collection upfront. So to create a new collection, you can say db.mynewCollection.insert, and my new collection will be magically created for you. Okay, with whatever data you provide in the form of JSON. Okay, that will be the first document. You don't have to create or define the collection explicitly, unless it's a different kind of collection, such as capped collection. And the document size, there is a restriction on document size. The document maximum size is 16 MB. And this is for whatever weird reasons, MongoDB guys have put this restriction as 16 MB. Okay. There is a lot of argument going on internet. Why should it be 16 MB? Okay. But for whatever reasons, they kept it 16 MB. So if you are trying to store a document bigger than 16 MB, prefer splitting it or try to use MongoFS for that. So Bhagwat's question is, why do we use nesting? As I described in this, I'll show you this diagram. You can see that my likes, the stuff what I like, is another object containing music, sports, and this is what is called embedding, okay, or nesting. This is also called nesting or embedding. So this diagram will give you an answer. Why do you need to do the nesting? Bhagwat, did you get the answer? Okay. And with respect to right, so yeah, so maximum 100 level of nesting you can do, not 100 nestings, meaning you at an object within an object within an object within an object. This kind of 100 levels is 100 maximum. Embedding and nesting are same, yes. Yes, Bhagwat, you got it correct. It is actually a pre-join table. It's a denormalized form of object. Okay. And there is another kind of special collection. It's a very different kind of collection called capped collection. It's like a circular buffer of fixed size documents. So this is a special kind of collection which is basically used in case of in case of how should I describe? In case of various kinds of data structure needs. Say you are building a mail relay server which can at most have 10 lakh documents, lakh emails in it. In those cases, what you do is you create a circular buffer, keep on putting the documents into circular buffer, while other guys, your reader, keeps on reading from it. Okay, and the moment you hit the tail, you stop there, you pause there, wait till the circular buffer becomes empty. Okay, there are few qualities of circular buffer. Okay, circular buffer is a fixed size. Uh, it can only have fixed number of documents. And as I described earlier, the strategy for storing the documents uh, and fixed. Uh, okay, so a circular buffer is having fixed number of documents. The moment you reach the tail and you don't stop there, you will overwrite your previous document. Okay, you will write the document which is on the head of it if you go beyond the tail and you start writing. So that's the property of a circular buffer. And you can create a tailable cursor on it. Tailable cursor as in, as you're writing, somebody else is reading, as I just described. So it's a circular table. One person is putting data into the circular this buffer and moves it, and then puts the data, moves it. The other guy reads from it and then moves ahead, and they both of them keeps on writing into this circular buffer. So the guy who is reading is called tailable cursor, and then there is a writer who is writing to the capped collection. The important part of the capped collection is it is good and suitable only if you are not changing the documents, because it follows the fixed document policy strategy as I described earlier. Okay, so this is for these special purposes, and MongoDB internally uses a capped collection for couple of use cases I'll describe later. Okay, so let me give another example. Say you are building a producer consumer. We all know that in case of any kind of system, for example, I was recently building a system where Amazon's images are processed. Okay, so a vendor who is providing the images for a product. So you are selling something on Amazon and you want to give an image to Amazon that hey, display this image in case of this product. This is what image I produce. So similar to you, there are hundreds of such vendors of the product who sell these products, hundreds of such sellers. And these sellers give out their images. And when that happens, so there is an update which goes in, and we read all of these 100 images and put it into a circular buffer, while our processor, the guy who is trying to read one image at a time and tries to identify it, is reading from the other end of the circle. Okay, so this way what it makes sure is that there is a conjunction. So there is a reading speed of reader and there is a writing speed of a writer. Both of them are doing some other jobs also. And if there is no circular buffer, they will be handing out to each other, and that's where their speeds will conflict. How should I say? They will not be able to do their jobs parallelly, and that's why we need circular buffer. Okay. If you have heard about queues, you have heard about circular buffers, then you will understand this analogy. So just like in any in an assembly line, one guy does some job, puts the stuff on the assembly lines and moves ahead, right? That's the job of a circular buffer or a queue. So this is what is called a capped collection. Okay. And this is how you create a capped collection. Unlike I said that you don't have to define a collection. You have, in case of circular buffer, you have to say db.create collection and then my call, and then you say capped equals to true and define number of records. And then when you are reading from it, you read from it. The same collection is you use db.mycollection.find. Okay. Now moving on. Now the CRUD operations, main CRUD operations. So CRUD operations mean C for create, R for retrieve or read, and U for update, D for delete. These are the four common operations which any consumer of the database does on the database. And create, update, delete are called write operations because they write data, and R is for read data. Okay, so uh, for reading writing we have like four mechanisms. I'll keep on describing. So C in case of normal SQL is insert into, and R is select star from table, and update is update table with these values, and D is delete from this table. These are the RDBMS analogies for these operations. Okay, so this is how a collection looks like, and these are the operations which we do on the collection. So a simple create is this. So you say db.mydb and insert this document, and this portion is a valid JSON. Okay, valid JSON object. And there are two forms. In one you specify your ID, and in another you don't specify your ID. The first line does not specify an ID. In that case, MongoDB automatically creates an ID. Okay. uh, okay, so in the first line we did not create any ID. We did not specify and enforce our own ID on MongoDB. So MongoDB automatically created an ID object for you, and then this way it created another object. We created another object by specifying an ID. I'm sorry. Now the interesting part. So say you are testing something and you want to generate a lot of data. MongoDB, this Mongo console is a very valid JavaScript console, and you can write JavaScript into it. Okay, so I will take a bit of time to show you these examples in maybe after these 4 slides. Okay. So you write your code in JavaScript. It's worth learning JavaScript because JavaScript is a very very popular language these days, as opposed to 1990s where JavaScript was considered, you know, very the programming language of people who don't know programming. But now when people have realized that the JavaScript is really powerful language in terms of all the feature sets, it has become the mainstream programming language now. And there are to me it has always been pretty good programming language because you are building a product and you need your own programming language, domain specific programming language. So instead of inventing your own, you can actually use JavaScript for your own product. And that's the beauty of JavaScript. It can be used in lots of use cases. It can be used in lots and lots of use cases. Okay. Great. So, okay. So Bhagavat is asking for a coffee break. Should we take a break for 5 minutes? It's already 8:30. We started on time today. Okay, great. Let's take a break. Today's class is going to be little big, and I might have to, maybe leave a portion for the next class, but we will go on our pace, whatever we can digest, and only then we'll move forward. Okay, nothing to hurry. We'll cover it up in upcoming classes. Okay. Okay. Great. Great. So let's meet after 5 minutes, which is 8:45, or maybe 6 minutes. Okay. Thank you. Okay. So I'm back. 1 second. Hi, I'm back now. So taking on Shakti's question. So in this particular example, second one, what Shakti is saying that I the key field is an object name or a unique value. So underscore ID is the predefined key. Okay. So anything, if you put the key as underscore ID, MongoDB will think that you are trying to specify an ID. And if ID equals 1 exists already in the database, MongoDB will give you an error. Okay, MongoDB will give you an error saying this ID already exists in MongoDB. Okay. Now, in the second piece of the code, we are going in a for loop. This for loop says that for I equals 0, I less than 100, I plus plus. So from 0 to 99, this loop will go on 100 times from 0 to 99, and it will insert an object containing a key as course and value as MongoDB suffixed with I. The value will be MongoDB as a string, which is suffixed with a number from 0 to 99. Okay. And can I share my, oh, what happened? What happened? Okay. So I'm going to show you on my screen all three examples. So first you go to the Mongo command line Uh, is the video available? I mean, can you see it clearly, or do I need to further increase the font size? Oh, right. Sakti is right that we are not specifying any ID, and the ID will be generated automatically for you. Okay, in the second example. Okay, just a second. So you can see my screen. Good. And now say I say mongo, and this is the command line I got. Now here, if I say db, it shows me my current database. If I want to use some other database, okay, let's say session 2. Although session 2 may not exist right now, if you want to see what all databases exist already, you say so dbs. So these are the databases exist already for my system, but session 2 does not exist. Still, it lets me change to a non-existing database. Okay, this is the meaning of schema free completely. And say db dot and say crud1. This is crud1 is just another any other like another collection I'm trying to create. And I say name equals mongo, name colon mongo, and curly braces close, and so this inserted an object called crud1. Okay, and to see what is there in the crud1, I say find, and this is what it is. So this object has got an ID and a key, ID as an one key value key, and name as another key, and this is how it looks like. So pretty basically formats it very well. If you have lots of complex object, it is good to format it with pretty, and it will give you nice output. So you can see that ID is an object, is something called object ID. It is defined in something called object ID, which is basically a random number uh, given by the MongoDB to you. Now say you want to insert an object with a pre-specified ID. Okay, like this. Now if you say db.crud.find, you will see that ID is 1, and if you try to insert the same ID again, it gives you an error. I tried to insert the same ID equals 1 again, and it gave me an error saying duplicate key error index such and such. Okay, it's a write error where it's not allowing you to insert a duplicate document. Okay, so that answers your question, Sakti. Okay, so Bhagwat's question is very valid. How is MongoDB making sure that ID is unique? So what is MongoDB doing is a combination of your process ID, time, and other random factors. There are a couple of more random factors. It adds to creating this ID, which is called pseudo random. There is no such thing called random in case of computers. It's always it's mostly random, pseudo random. Okay, so to generate something a pseudo random ID, this is what we do. It's basically it is a combination of process ID, time, and some more factors which are taken into consideration. I'll send you a link which points to the code in MongoDB which generates the ID. Okay, that will give you a better picture. Shreya's question is, when querying collections or document, no need to specify ID. It is up to you when you are querying. I will come to the querying part in the rest of the talk. Okay, because querying is something which requires a lot of attention, and you can specify ID or any parameter and can get it outputted. Uh, okay, but when user is okay, okay. Bhagwat's question, Bhagwat, can you just complete the question? But when user specifies the ID and the data is inserted over several locations, cap theorem. Okay, I'll give you some time to compose your question, and then we take up your question again. So, and the other part, good part about this console is it's actually a perfect your JavaScript console. So I can write variable a equals 1 and then say and loop it over, or say a equals a into 30 into 50. Okay, and actually you can use it as like simple calculator also, but that will be like overkill. Okay, so it's a complete if I have a for where I equals 0, I plus equals 2, and I less than equals 100, this basically will give out all even numbers from 0 to 100. Okay, or you can yeah, so 0 to 100 it gives. So what I'm trying to demonstrate, that this is a very powerful tool. From the console you can interact with your MongoDB using a proper programming language, unlike the times of your other databases where their console never provided a full-fledged programming capabilities. So you always have to learn their domain specific language. Like iteration in case of a MS SQL is different from iteration in case of your mm, uh, um, iteration in case of your Oracle database, and it becomes a very domain specific knowledge. But in luckily in case of MongoDB, the console itself supports complete JavaScript and also supports a Python language. And from programming like Java, in language like Java, you can interact with the database again similarly. So effectively, you get a powerful console. Say you want to insert 1,000 documents. I'll demonstrate how to insert 1,000 documents. So here I say db dot insert db dot I'm just putting a name called bulk for my collection and saying key plus I, and let's say I want to just keep it I plus plus, and value I would say that I would like to call it I into 2. Okay, so all I'm trying to show you is how you could combine your programming. Just a second. Okay, so this way I have inserted into the database. Okay, and here if you want to use like this, and if you say db dot bulk dot find, and this gave you a result, in which all the EV numbers are there. Okay, and this has generated this. I want to actually try a couple of more things. What if I give I? Okay, so let me just go back, and you can drop a collection just like that. You say db dot your collection dot drop, and it get dropped. And I say this, and so okay, so db dot, I say use session 2 and show collections, and then I say db dot bulk and then find one. Okay, I think it will be difficult to put name as in where name equals I plus like this, db dot bulk dot find. Okay, so db dot bulk dot drop, and then I try to insert again db dot find db dot bulk dot find. Okay, so basically it's not accepting a variable name in the key. Okay, for whatever reason, but for the rest of things, you can put your variable names like this. So I'll go through this code once. So it says that go from 0 to 100 and insert a double of the number. So from 0 to 200 the value will be there, and these are the documents inserted. So the whole purpose of demonstrating this is that you can combine your combine your okay, so sometimes asking what was find one. Find one is equivalent to showing a particular record, only one record. It's equivalent to limit one, and it also does a limit one and then pretty. It formats the whole document into pretty format. Okay, okay, okay. Let me now attempt Bhagwat's question. Since the data insertion can be spread across different servers and data consistency is not guaranteed, how can MongoDB make sure ID is unique? Since the data insertion can spread across different servers, and so basically it has a lot of parameter to generate an ID, and then it create after combining all those parameters, it does an MD5 hash on top of it, which is very 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 randomized, and hence it is I mean it has been considered a fairly random number. It combines an IP address, it combines a machine name, it combines a process ID, it combines a couple of more couple of more things while generating an ID. Okay, so it has been fairly accepted by developers all across that this ID, I mean this generation of ID is a common process across all other softwares also. Okay, so you can be rest assured because in Android and everywhere it's the same process of generating ID is used. Okay, so this is what it is. You can go, I mean, the whole JavaScript you can use from the console, and it is quite handy. Say you want to read from one collection, do a minor churning, and put it in another collection. You can do from the console very quickly. Now I'm sharing back my presentation. Okay. So then Crud is the second letter in the Crud is R, which is retrieve and read. As I just demonstrated you, db.mydb.find is gives you all the records in MyDB. Then another way to go over the record is assign the results of db.mydb.find to a variable. In this case, the variable name I have given is t. Okay, and then you can iterate over t to get the next record. By default, when you say find, and if there are more than 20 records, it shows you only 20 records. And then if you type it, it goes to the next set of 20. In the first one, there are two ways to use. First one is simple db.mydb.find. It will give you only 20 results. If you type it again, then you will go to the next iteration of records will be next set of 20 records. So it gives you a result by default in batch size of 20. And if you want all the records, or if you want to do more operation, say you want to read one record and insert somewhere and then read another one, then do some other churning. In those cases, the second syntax where you go over this database and first create a cursor, we call it cursor, by using where t equals db.mydb.find, it will just create cursor, it will not print anything for you. Okay, and then you say while t has next, print t.next. Okay, so till the point this cursor has any element left, this loop will continue, the while loop will continue, and then you can print each object one by one. Or if you want to insert into another database, you can do that here. Okay. So instead of print JSON, you could also say my db.mydb1.insert. So you are taking the data from one collection and putting it in another. And this is very useful construct when it comes to controlling a lot of things. It gives you a very handy control of moving data from one place to another, or do all sorts of data import or churning jobs very quickly. Okay, and specifically for QA guys, this comes very handy. You can generate the data very quickly and you can do all sorts of magic. So Bhagavat's question is, when user specify ID, what happens to the data insertion across the different servers? If you are specifying your ID, you will have to take care of the ID generation process by yourself. And in case your ID is not properly generated, MongoDB gives you a way of creating a hash out of your ID. If your ID generation is not very uniform, you can create a hash out of your ID and use that as the key for distribution across the network. That is called hashed key sharding. Okay, so I think I could answer Bhagavat. And Sakti's question is that how to retrieve based on same condition. For example, extract all employees from Bangalore and who. Yes, I'll come back to that. I'll come back to that very quickly. That is the whole essence of the talk. Okay. And then the second syntax is just to find any single record. You can say db.mydb.find1. Okay. And then if you want to find a particular record, say you want to find a record which matches course colon this, then you can do that. And you can combine, as Sakti was asking, you can combine like this. It says extract all employee from, so in the find what you do is location Bangalore, okay, and location Bangalore, and then salary XYZ, wait, we are not typing. I am not typing on the command prompt right now. Salary 100. Okay. Now the question is how do you say salary greater than 100? I'll come to that one just now in the next screen. Okay. Now let's just go over update quickly. What does update look like? Good, good. I have that. Okay. So similar to read, we have some similar to find, we have update. In update, the first section, the first row here, this portion, I'll select this. This is same syntax as what we use in find. Okay. Basically, we are saying update all the records whose ID is equal to 1 and update a key called course with the new value as this one. This is my new value. So what it will do, it will find my in my DB collection. In my DB collection, it will find the object with respect to ID equals 1 and update the value course with this new value. Okay. And then we have db dot people. Another syntax is this on the right hand side, which says find all the people whose name is Andy and set the name as AY and rating add one more attribute called rating equals 1 and upsert equals to true. This is new. Upsert means in case there is no Andy existing in the database, create a new document with these two values. Instead of updating, it will create a fresh document because there was no document found. Okay. And multi equals true means in case there are multiple Andys in this collection, it will update all of them with these values. If multi equals true is not mentioned here, it will only update the first document found with respect to the criteria. This is the criteria. Okay. So first section is criteria and second is new values and third is options. Okay. So there are three objects we pass to update function. This is the first one. You see the comma separated and the curly braces. So this is the first one. This is the filter criteria. And then second one is the updating values. This is the new values you are trying to set. And this is the options which we are trying to set. Okay. Upsert means create a fresh record and multi means even if there are even multiple records existing there, update all of them. Yes, in first case, because ID is unique, it will update. But in the second case, since we are not using ID, and so all the documents containing this particular value will be updated. Now there is a third syntax where I say find all the stocks less than 5. Okay. This is so this same syntax is also used in case of find. Okay. So in case of Sakti, as you were asking, you can also say GT here. LT $LT means lesser than 5. Find all the books whose stock price is less than 5. Okay. This is what this syntax says. And then set reorder equals to true. Okay. Reorder is one of the values which we are trying to set. Set reorder value equals to true. And then the options. Multi equals to true as I explained earlier. Multi equals to true as I explained earlier. And then we define write concern. Write concern means how much guarantee are we expecting from MongoDB. MongoDB should not, should respond back to you when it has done this much of write concern. So write concern could be various level, such as, do I need to does MongoDB need to report back to you when it has actually finished writing to the disk, or it has finished writing to the journal, or it has finished writing to the primary nodes, or it has finished writing to the secondary nodes. Okay, so this is the write concern. I'll come back to that again. That's what is the whole talk about. Okay. And then there are various update operators, such as increment. If you say this is the update operator. You see set is basically saying that set a key called reorder to a value true. Okay. So by default, as in this one, this is actually by default a set. We are trying to set course to this new value. Okay. So you generally don't need to specify this specifically. Okay. Because it is by default set. And now, if you say inc instead of set, it will increment a value by 1. So say we have got all the records here. Okay, wait, I will share my screen, and then okay. So, and then you can multiply. If you want to multiply a value by some other value, then you can also you can use multiply operator. And if you want to set value of the field, unset, if you want to just delete a particular field from the document, then you can use unset. And you can set the current date. And if there is a set, as in there is a array of values out there, then you can add an element to it. Say if the value is of type array and you want to add one more unique value to that array, then you can use add to the set. If you want to just append one more value to that array, then you can use push. If you want to remove one element from an array, you can use pop. So I will demonstrate you inc first. And inc is an atomic operation. Either it happens or it doesn't. It doesn't leave you in between. Okay. So I'm going to share the screen again. Can't you just multiple select ones and be happy? Okay, don't. So this is my Mongo. I say use session 2, and then I have db.bulk.find. Okay. And say so I have 1, 2, 4, 6, 8, 10. So can you see my screen? Good, good. So db.bulk.find. First I'll just drop this. Drop, and for I equals 0, I less than 10, I plus plus, I'm going to add name, let's say v equals I, and db dot my collection dot insert, and then object started, object ended, and then insert ended, and then my for loop ended. Okay. And say db.myCollection. And also remember, you can press tabs. Don't think that I'm typing pretty fast. Actually, it's helping me autocomplete when I'm pressing tab. So I have inserted in my call that 0 to 9 numbers, and I can do update. And if I give no object here, if it's empty, that means I'm trying to select all the objects. Okay. And then I say inc. Okay, inc colon, it takes a value, and then I want to increase this value by 1. Okay. Oh, I think I missed again. I missed one curly braces. So I've increased all the values by 1, and oh, I haven't set multi equals to true. Oops. So here I need to set multi equals to true. So it says modified 10, and that's it. Okay, so the first record is incremented twice because we had incremented in earlier command also, and the rest of the documents, rest of the values are incremented now. Okay, if you want to just multiply 8 by 10, so all of these numbers are multiplied by 10. Okay, and if you want to say unset and say v, so the v is deleted. If you see, I have said for all the records, which this is empty, for all the records such and such, unset v colon 1 means true, and it will delete the v which we just set earlier from all the documents, and that's what it did. Okay, and say if we want to uh, you know if you want to say set, we put a dollar here, and we say, and we just created this. Okay, and you can see that it has created v as an array. By default the value is contained in this. Okay, and now what you could do is you could say uh, you know and then you can say push. So I have appended 2 to the array. Okay, if I use push operator, it will append that value to an to the value. Okay, and this is the way we do it. Okay, and you can combine these operators one after another, like multiply and everything, and you can use you can modify your content. So we talked about how do the various operators in update work, and we also touched a bit upon find. So similarly, add to set, we talked about add to set is similar to push, but only unique elements. If they don't, the new value does not exist already, then only it will be working. Okay, now getting back to my usual screen. Just give me a second. Okay. Okay. Um, so let me just go over the quick questions. I have a question. I tried the update on your previous example when I used a new key and value pair it replaced the old key. So I mean Bhagavati, you can, yes, I mean that's the way it is supposed to work, right? So just try a couple of more times and also just send me the screenshot and then we will discuss. Okay. So basically you did a insert and then trying to update. I think it should work fine. Okay. I hope things are not no, no, no. So when you are updating, you are not changing the key. The ID of the document will remain as is because you have not tried to change the ID. ID will remain as is. The other attributes of the object got changed. Okay. And if you are trying to change the ID, I think it creates a separate document that I need to experiment, or maybe it will give an error. Okay. So moving on. And the simple syntax of deleting is similar to update, but only the first parameter of the update, which means all the things which you write in find command, you can also write in delete. So whatever criteria you can specify in find, you can specify in the mm, delete also, and you can delete selectively. So this is nothing new about delete. Now, because there are a lot of operations which find can do, I touched upon find very briefly earlier. So let me just start with something called read operations or querying. So from now on, we will be talking about two parts. One is read operations and rest is write operations. So first is read operation. In read operation, there are basically three things. One is find command. Other is aggregations, and other is MapReduce. So aggregation and MapReduce are for advanced level of querying the database, where MapReduce and aggregation work on the network cluster, while find is good for a single computer. Okay, so if you have a big network, you preferably would use aggregations inevitably and MapReduce, but the syntax in aggregation will remain as what we are going to describe for find. Okay, so right now let's just okay. No, find will actually be distributed. Find will be actually distributed. Only few other commands are non-distributed. Okay, so find, map, reduce, aggregation, all three cater to the similar need of reading the data and finding the particular records from the MongoDB. Okay, I was expecting a new key, but it replaced the existing key. No, when you are trying to update a record, it doesn't change the key. Let's discuss it after the class, one to one, and I would like to see what exactly is going on. Okay, and we will discuss it, and if required, we'll let others also know. Okay, 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 okay. So find has like a few parameters. First one is your the collection which you are selecting. This is users you are selecting here. Okay. And then second one is this is a query criteria. And third one is what columns to select. This is equivalent to SQL query, just in a different order. In SQL query, we first select what are the columns do we want, and from what table, and what is the criteria, and then cursor modifier. Cursor modifier can be limit or can be sort. Okay. So we first said age greater than 18, and then name true, address true, means we want only these two columns. Okay. We want to just see only name and address in the default, and when we are, whether we want it or not, ID will be selected by default. We will have to turn off the ID by I mean this will actually give you three columns: ID, name and address. Okay. So query behavior in case of MongoDB is with respect to the always a single collection. You cannot query multiple collections at the same time. Okay. And that's a something which people are arguing about, because MongoDB, as per the philosophy, gives you the query only on the single collection. And default order is undefined, but generally it is based on the ID creation. Generally the order in which the ID is created is the same order it's printed. You can impose limits, skips and sort orders. Limits is I want only 10 records. Skips is skip first 10 records. And then sort orders. So give me the result in terms of sorting. So the third part, first one was your query criteria, second one was projection, and third one was your modifier. So third one can be limit, skip and sort. Limit is for limiting the number of records you want. Skip is for skipping the records by that many, and then sorting is by sorting. Okay. And after sorting, you can again apply limit or skip and that kind of thing. So you can apply modifier interchangeably. So here it's showing you that you selected first you apply the query criteria, then you applied the modifier and you got the result. And in case of sort, again it's JSON. Everywhere is JSON again. So sort, it says sort by age and 1. 1 means ascending order. If you say -1, it will be descending order. Okay. Here this means, this particular part means that we are saying sort by age in ascending order. Had we put -1, it would be descending order. Okay. So if you can see here, okay, so I will have to maybe, and also on the Unix part, right, you can press Control R to find your previous commands, or you can press up arrow key, down arrow keys to find your previous commands. Okay. And let's say I'm dropping this and I'm trying to create from fresh. So I'm saying add value here, db.mycall.drop. Oops, I was supposed to say find here, and then I say sort by V, and I say -1. and put curly braces both the sides. So it's sorted. If you can see, I sorted by descending order. Okay, and say I want to put a projection. I do not want ID, for example. So first I define my filter criteria like this, which is empty, and second criteria is my second object is my projection. Okay, so this will only print this will not print ID for me. Okay, and if I say v dot 1 is equal to the same thing, and if I say v dot 0 also, it gives me empty results. Okay, when I say 0, it means I don't want that column. V colon 1 means I want that column. Okay, so this way you can do. But what you cannot do is, if you have two columns, basically uh, say you had, let me just do one more thing. So let me just for drop. Okay, and then I say insert, and in case of insert I put one more column, c equals I into 3, and I say db dot find db dot bulk dot find. Oh, I have inserted into my call. Okay, I just drop everything. Then I'm trying to add two columns, v and c. V will have uh, values from 0 to 10, 0 to 9, and this will be thrice of this. And I say db.myCall.find. It gave me this. Now what I want is I want only I want only c, for example. Okay, so what I do is c equals 1. So if I say c equals 1, not this. So ID comes by default. We'll have to turn off the ID by ourselves. So ID gets turned off. Okay. So basically there are two ways of setting the projection. One is exclusion and one is inclusion. When you say 0, 0, 0, 0, it means I'm trying to exclude that particular column. And if I say my column name column 1, I'm trying to only include that. And the interesting part or the irritating part, whatever you can want to say it, is that you cannot mix inclusion and exclusion together, except in case you are trying to exclude underscore ID. Okay, so as a thumb rule, you cannot mix inclusion and exclusion. Inclusion is when you say I want to include this column in my result. When you want to see the results on a collection, and you say you only want to see this column. In those cases, you say your column 1 in the second parameter of find. Okay, and you cannot mix inclusion and exclusion together, but you can mix the ID exclusion. Okay, so this is a little confusing. I'll give a visual example here. Okay, exclusion I will discuss probably in the next slide. And these are the various kinds of comparisons. We talked about greater than. Okay, we haven't talked about greater than actually. Here, age greater than 18. Okay, this is the criteria, and this is my search operator, query operator we call it. And so basically this criteria is also called selector criteria, and we have multiple operation. GT is greater than greater than equal to in. If you have an array and you are looking for a particular value, then you use in operator. So if you have an array of values in your document and you're trying to look for all those document which has this whose value exists in the specific array, then you use in, and then less than, and then less than equal to, and not equal to, and not in. Okay, let me have a look at questions. I have not replied to anybody's questions. Okay. So Bhagwat is saying, does that mean one should have the DB self-contained with all joins pre-computed? Yes, Bhagwat, that's the idea. That's the idea being adopted by lots of people, where in uh, we people try to store an object altogether. The way not really. It looks like data duplication, but it is not. Okay. Lots of people say, why are we specifying key again and again? Why couldn't we just define that in table while creating the table? Why couldn't we just create the column headers and not this? It's not data duplication. Look at the brighter side. So we are sacrificing a bit of space, maybe 10% more space in favor of ease of programming. Okay, you don't have to use any kinds of convert this object into the table and split some data from this to this table and split some sub object somewhere else. So since everybody is using object oriented programming, it becomes very easy to use a MongoDB kind of a system where you can actually store only the database, only the object edges. Gaurav, it's similar to what Lucene provides, but I mean, it's it's also very different because Lucene has got a different query structure. Okay, here everything is mostly JavaScript, basically JSON. Okay, Sakti's question is, can we give a give like this? So what you do is you put a comma between. These should not be separate objects. So you say sort curly braces location colon 1, then comma salary colon -1. Okay, so it will first sort the data by location in ascending order, and then sort the data by salary in descending order. If there are two people in the same location, the person whose salary is lower will come at the bottom. Okay, so you can combine those things that way. Okay, probably this is what you're looking for. Okay, so yeah, so Bhagwat, your question regarding the key existing, probably we should discuss in another thread. And your second question I have tried to answer because it's a philosophical debate. Okay, it's a philosophical debate. The whole half of the internet is full with that. Whether object-oriented database suits any need or not, is it a wastage of space, and that kind of thing. Okay, and but it's a valid question anyway. It's a valid question. That's the first thing that comes into my mind. Okay, so basically we sacrifice a bit of space in favor of saving a developer's time and making a system more robust and simple for the newer kind of needs. And that is why people use a document oriented or object oriented databases. Yes, definitely performance gain is far better, because imagine you are building something like Facebook and you have hundreds of parameter, and Bhagwat likes this, Bhagwat likes that, and Bhagwat's about information is this, about information is that, and
you have to display that information. Either you could create thousands of table and query them and join them together and then try to do all sorts of magic, or you could simply just query an object and present it to the user. It's as simple as that. Okay. So definitely there's a huge performance gain, and lots of systems use MongoDB just for caching purposes instead of using any other software for caching. Caching is something you keep in memory. Okay. Or on a network system which is fast, you compose objects, give it to a server which keeps object as is, because computation of an object takes a lot of time in case of relational systems. And hence, there is a huge performance gain provided by these guys. Okay. So these are the selectors which we call. And then there is a logical and or operator. Okay, this example should give you a good idea, and I think I should just format it for you. So as you can see, there is a okay, you have these kind of objects. Okay. Hmm. Good. So you can combine your and or like this. So say you want to say get me all the records which are either for course called MongoDB or by Sandeep. So you want to find either or. In those cases, the first you say or and then array starts. In an array, each portion is an object where key value is defined as filter criteria, and you can further put equals to and or equals to in, and those kind of conditions you can keep on chaining. So if you have to put instead of this, you could have to put in, then you would do this like this. Okay. So this is how you define or, and you can also put and. And is redundant because in find all the things you pass in are by default and anded with each other. Okay, not dollar here like this. Okay. Similarly here, you said and this is redundant. This is equivalent to saying comma colon Mongo comma by Sandeep. Okay. And similarly there is a not operator. We want to say it should not be by Sandeep. By and then colon, then not operator equal to Sandeep. Okay. And then nor. Okay. So it's a logical nor join for you. Okay. So these are the various filtering mechanisms. These are the various filtering mechanisms provided by uh, these are filter syntax of the find or syntax of the querying mechanism or filtering mechanism provided by MongoDB for the users and developers. And so basically you keep on chaining your um, find command with operator colon operands, and operands could be further an object or further an operand, and so on. Okay, but everything will be in the JSON format. Okay. So Gaurav's question is, Yes, very valid question, Gaurav. Gaurav's question is if we can use Mongo for caching, then we can say that we can use Mongo in place of Hazelcast etc. for distributed caching or messaging queue. Hazelcast is not very good for caching large data. So yes, lots of people are using MongoDB for caching. Okay, and MongoDB comes in pretty handy because I mean, although it doesn't compete head to head against people like Memcached, whose role is only caching, but it does provide a bigger value against all of them because memcached, for example, is string and value. Okay, it becomes difficult to communicate back and forth with memcached. Okay. So people are actually replacing their cache servers, but still they don't MongoDB, they themselves don't say that we are a caching server. Okay, so their design paradigm is not oriented towards caching. What does cannot mix exclusive and inclusive mean? I will come to that very quickly. Okay, it'll be interesting. Okay, okay. I think I have a next. Say, okay, okay. Here. So these are the examples actually in the same screen. So here projections are for selecting. So we talked about normal operators, comparison operators. Then we talked about logical operators, and, or, and not. Then we are talking about projections, the second part. So projections are something which select or deselects the field. Selection means including and deselection means excluding. In, and you define by column 1 or column 0. When you say 1, show me only that column. That's the meaning of inclusion. If I say name column 1, it means show me only that column. But by default, ID is also selected. So it's a sort of a little way of MongoDB is saying, yeah, that unless you say explicitly that you don't want underscore ID, I'll show you underscore ID. You can turn off all the question. So the moment you explicitly say I want to see column 1, so all the columns except for column 1 and ID will be hidden. Okay, ID will have to be explicitly turned off, underscore ID column 1. Okay, and in exclusion means that show me all the columns except for this column. Okay, if you are specifying only a field with a 0, you cannot specify another field with 1. Okay, there's the very very simple words. You can either specify inclusion or exclusion. Okay, there is only single exception to this rule where you can exclude underscore ID in case of an inclusion syntax. For example, this says don't show me history column, show me all the columns except for history. Okay, and this says that show me only these two columns, name and email. And this says show me name and email, but don't show me ID. This one will show you three columns, name, email and ID, and this one will show you two columns, name and email. Okay, so that's in very very simple words, that's what it is. Okay, and when you will be attending the quiz, you will get your answers very validated. Okay, so cannot mix exclusive and inclusive except for excluding ID. Okay, like in this case, this is the only exception you can have. Otherwise you cannot mix something like this, something like putting one more here, say n equals 1. This is invalid, this is invalid. Okay, because you are mixing exclusion and inclusion. Okay, so hope I answered your question. Now let's talk about cursors. Okay, we talked about this syntax, but I forgot to give you a demo of this part, where we say that db.mydb.find and assign it to var equals x. This will not print anything on the screen. Instead, it will create a variable x, which is basically a cursor. Okay, cursor is a synonym to a role which is displayed on the right hand side, where we see only a window of the whole document. This is a small window, and rest of the data is hidden under the roles, and you every time you go to the next, the role moves on, and that's what the cursor does it. In case of Mongo shell, it gives you 20 results only, and if you want to see rest of next 20, you say IT, and that's what the role of a cursor is. You can define, you can use a this config option called dbquery.cellbatchsize to change it, and you by default the cursor timeout is 10 minutes. You can change the cursor timeout to infinite by using this option of no timeout. Okay, this is the no timeout option. Okay, and when you want to see how many more objects are left in the database, you say my cursor.objects left in batch. Okay, try these commands by yourself. I have shown you in this syntax, uh, in syntax above, like this. This is the usage of a cursor. Okay, this is the usage of a cursor, this portion where I created a cursor then moved on. Okay, so okay, and the other part is, if you are writing a data to the collection and you have also opened a cursor on top of it, you might see multiple records, because MongoDB per se does not stop you from the reading the dirty data. Dirty data as in somebody else is writing the data, they have not finished writing it, you can still see that data. Okay, this is done in favor of the speed, and I mean, it is in the done in favor of speed over the consistency. And to avoid this kind of problems, you may like to go for something like snapshot mode. So you say this collection is in snapshot mode, and then you keep on going. Okay. And what all cursors are being used on the server, you can see from the server status. Okay. This is a bit of theoretical, simple commands. So if you say help, db.help, you will see lots of commands. One of them will be server status. So you say db.serverStatus. It will show you detailed information about your server. And then from that, you can see your metrics, your cursors, or everything you can see from there. Okay. Okay. I will cover up to query optimization today, and then rest we will talk on later. Or should I stop now? Because it's already 10 o'clock. Nothing to hurry. I want to spend. I want to spend. You know. Okay. I think we'll stop today. and we will discuss it on next Saturday. Till then, go through the quiz, and the moment you reach cursors, you can stop the quiz. Okay. And assignment, I'll just go over the assignment once. Okay. So first assignment is that uh, create 10,000 documents using MongoDB. Okay. Iterate over your cursor and try to print the data in capitals. Okay. Iterate cursor in Mongo shell. Print your data in capitals. Say you created names Mongo and now you want to print it in capital. How do you do that? Okay. So try to do that. And how to find inactive cursors. Okay. This you can see using db.server. You try doing all of this, and this is most interesting aspect. Whosoever can solve this one will be really appreciated. How can you create an auto incrementing sequence field using what the knowledge we had? So the last slide which I have, this slide is uploaded onto the server. Okay. And you can actually answer all these questions based on what has been taught today. Okay. You can answer all these questions based on what has been taught today. So assignment, not finishing assignment is, I mean, you can't give the excuse that the class was not completed today, because these assignments, whatever is required has been taught today. Okay. So there's a most crucial part. Oh, sure, Umang, sure. Let me make a note of it. Yeah. So, and Umang, why don't you use the server which I have created? Okay. Why don't you use that server? And okay, great then. So we are done with it. And in the next class, we will basically talk about a couple of more things. Okay. And for in next class, we'll talk about data modeling and whatever is left today. Okay. Yes. Please, Samta, please email to MongoDB at nobigdata.com. Okay. Okay, great. See you on the next Saturday. Finish your assignment and submit it to me. And spend enough time with the find operator, because the thing which is going to take time is your ID, understanding the syntax. Okay. If you are able to clear the syntax, everything is great. Okay. Okay. And reference guide is basically, if you search in Google, right, the documents which come from MongoDB, okay, the docs which come from MongoDB are pretty good actually. So the guide which will work well for you guys is this. This is the reference, okay, and you can use that one. Okay. Great. See you on next Saturday. Bye bye. Thank you, Shreya, for the link. And feel free to get in touch via email or via phone in case of any doubts. Bye Gaurav, bye Bhagwat, bye Samta, bye Sakti, bye Shreya, and Umang has already left. Great.
So Umang has to get the answer on Umang has to get the answer